Hi everybody! In this video I would show how we can set up a glow effect on a selected sprite in a 2D project. Such a shader may come in handy if we want to understand how the glow calculation works, or if we decide to work without setting up a global glow in the WorldEnvironment node. Let's do it. So, as I was saying, such a shader can be very useful if we don't want to deal with setting up the world environment, or if we want greater control over the glow effect of individual sprites. I'll start by creating a simple scene with two Sprite 2D nodes, one for the background and the other as a sprite that we can use in the game. So where is it here? Scenes, right click, create new scene. Let's call it glow, for instance, and OK. And now, as I said, first child node would be Sprite 2D. Here it is. And I have this kind of image, which I already used in previous video. So let's do it again and center it. No, disable the centering, of course. So here it is, and now, okay, scrolling is sometimes buggy. And the second one, so I will call it background, I'll leave it as this, duplicate, and this one I'll call spaceship, because that's what we will add there. Okay, here it is. If I disable this, we can see it right here. So I will start working with the background. Let's switch that and select the node, and we need to add a new material, which would be shader material, of course. Click and create the new shader, which we will call glow, and put it to the shaders folder. Okay, create and click to open in the editor. I will just move it up a little bit. And now the shader itself. The simplest glow shader can be written in just one line. It might not be very powerful or capable of much, but it could suffice for certain basic cases. Let's do it. So let's get rid of the vertex function. Definitely don't need that. And comment it out, light function. And here we will work with something as uniform parameters. First of them would be the color we want to use for the glow effect. The color would have RGB components, so let's make it vector 3 and call it glow color with a hint source color, and the initial value, for instance, 0.2, 0.6, 0.3. It is a shade of green, I suppose. And the second one, uniform float, that would be glow power. This is simply intensity and intensity of shining of this color. And I'll give it a hint range from 0 to 8, let's say. Step 0.1, and the default value would be 2. Alright, and now the promised one-line shader. So we need to change the color of the particular pixel and take the color from the texture, which is in this case this image, this background. And so this is the variable texture, and the pixel is equivalent to current UV coordinates. And now we need to multiply that by vector 4, which consists of the glow color and alpha value 1 multiplied by the glow power. Okay, that's it. Let's wait for it. And now we can see it's green. And if we work with the shader parameters, change the power, you can see it glows more or less, or completely disabled. And of course we can change the color if we want to make some other effects. Very well. Let's Where is it? Oh, sorry, I disabled the shader. Let me revert that and revert the original values. Very well. Okay, let's see how it works with the spaceship sprite. First of all, I will save this glow GD shader so it can be reused for the other sprite. And now just disable and enable. It's necessary to create a new material because materials are resources and are generally shared. If we use the same material as for the background, we would just change parameters in one of them and it will be changed in the other one as well. That's not what we want. We'll create a new shader material, but what we can share is the shader code. Simply use quick load and find the glow effect. Where is it? GFG. Is it somewhere? Oh, I better find it. Glow here. Okay. Very well. We can see it is already. It already changed the color, and again, if I change the glow, it is doing something. It is a very basic glow effect because there is nothing like color bleeding or bloom or anything like that, but as I said, it can be okay for some use cases. Anyway, we are not finished. Let's improve our algorithm. So the main drawback of this solution is that we simply replace each pixel with another, which is quite a straightforward algorithm that doesn't allow us too many settings. The only thing it can modify is the color and the intensity. We can achieve a bit more flexibility by mixing the original and the new pixel using the alpha channel. So instead of vector 3, we will use vector 4 to define the glow color. Let's do it. Vector 4, and let's start with just fully opaque color. Alpha is 1.0, and of course vector 4 right here as well. And now we need to make it a little bit different. So first I will create vector 4 as the current pixel, which is basically this part of the code. Let me cut and paste here. Now we will calculate the glow. That is equals the current pixel multiplied by the glow color multiplied by the glow power, so it's basically the same. And finally we will combine these values using the alpha channel, so it would be mix function, which is a linear interpolation mix between the pixel original color, now glow, new color, and the weight value would be the alpha value of the glow. Let's see. Yeah, here it is. And now if we select the color and change the alpha channel, we can see, or maybe not. Surely it would be better with the other sprite, so let's activate that, select, and now we are already using the new version of this shader. Let's select the color and change the alpha channel. We can see that it is slowly blending with the gray background or getting back, and maybe I increase the glow power. Okay, and color again. Yeah, there is definitely, this is another way how to fine-tune this value to reach the effect we want to use in our game. Okay, this is definitely a usable effect. However, it still only works with the current pixel and does not take its surroundings into account. You may recall that combining a pixel with its immediate neighbors in a 3x3 matrix was successfully used for the Sobel filter and Gaussian blur in one of the previous videos. Now we will try to utilize the same principle for an advanced pixel glow. Let me start by adding two new uniform parameters that will control the radius and blurring of the resulting glow effect. So it would be uniform float, I'll call it glow shift, and give it glow shift, and give it a hint range from 0 to 10, and the initial value, let's start with 1. Okay, And the second one, uniform float glow radius with a similar hint range, but starting at 1. We don't want a 0 radius, of course, to 10. And this time I think the step can be 1.0. And again, we will start at 1 as a default value. Okay, and now the improved code. So first, let's start with, we will calculate the final glow value using 2 cycles. So we need to start at something and add new values after each cycle. It would be vector 4 with 0 components. And I will also add a variable, float variable count, as we will need it to normalize the final value starting at 0. And now the cycles for float x starts at negative glow radius, x less or equal to glow radius, and x increased by 1. So for instance, if the glow radius starts at 1, it would be from -1 to 1, -1, 0, 1. If it's 2, it's -2, -1, 0, 1, 2. Okay, and similarly, we will create the second cycle for y. Y and this to have the whole matrix 3x3 in this case. And what we are going to do in the matrix, we create the offset, which will simply give us coordinates of the particular pixel in this 3x3 matrix. So it would be offset equals vector 2 with components x and y, and multiplied by glow shift multiplied by texture pixel size. This is basically just size of the pixel of the particular texture, so it would calculate this offset correctly, as the pixel size can be different for different textures, of course. Okay, and now we have the offset and we need to add a new value to the glow accumulator. And again, we will use texture of the current texture, and this time UV coordinates increased by the offset, so we don't forget to calculate the neighbor pixels multiplied by glow color. Okay, of course we need to increase the count by 1. Very well, that's everything we need in these 2 cycles. And now we don't need this row, we don't definitely need this, and instead we will normalize the results. So glow would be multiplied by the glow power, so we don't forget about that, and divided by count. All right, and finally we don't have the pixel anymore. We will simply copy and paste this, but without the offset. UV, glow alpha. Very well, let's see what happens if I change these new parameters. So radius 2, 3, 4, 5. Can you see how it's blurring? I'll enlarge it a little bit. 10, and now let's change the shift. It's blurred even more. We can see even some pixelations over there, and increase the glow power. Now we are getting something. This is very nice, I guess. Okay, so we have a lot more parameters to work with and reach the glow we want to use. So the advantage of controlling the glow through a shader is that we can use it individually for each sprite in our game, All we need to do is assign such a sprite a new shader material with this simple shader and set the parameters as needed. Let's try it out and make a few copies of the spaceship sprite node. But first I think that we should have a black background, so I will add a color rect, put it as a first child node, set the color to black and change the dimensions. I think we have full HD. What the? Numlock, sorry. 921 and this. Okay, so this is our first ship and I click Ctrl D, spaceship 2. Let's move it elsewhere and check its material, cancel and create a new one. Shader material, click, and we will reuse our shader. Glow, here it is. Okay, as we can see, if we change the parameters, it doesn't affect the first ship because we have two different materials. Okay. Something like that, for instance. Cool. All right. And of course, we can also dynamically control these parameters from GDScript. For example, like this. Let's create a new script, call it glowgd, create, and first of all, we will add a reference of the, let's say, first spaceship. So control and release, we created this already declaration, and now we will need something to control the glow change over time. I will call glow power. Power that starts at 1 and speed of the change that would start at 2, for example. No semicolon here, only in the shader code but not in GDScript. Okay, we don't need anything in the ready function, let's get rid of it, and now we will do it in the process. So first let's make sure that the spaceship declaration is finished, it's ready, is initialized, so we will do it only if it returns something else than null, and now glow power would be increased by delta and multiplied by speed, and we need to rotate it up, down and something like that. So the simplest way would be, for example, if glow power is greater or equal some edge value, let's say 4, and we are currently increasing the speed, or if the glow power is less than some other value and we are decreasing the speed, or the speed is in the opposite direction, sorry. In that case, let's change the speed direction. So if it's positive, we'll make it negative and vice versa, -1. And let's send this new glow power value to the shader. So we need the spaceship, get material and set shader parameter, which is glow power, as we have it here as the uniform parameter, and the value is glow power as we defined it here. Okay, that should be everything, I guess. Okay, but one thing is not correct, means to indent is correctly, because it should change on each frame, not only when we modify the speed direction. This is very important. Let's try it out. Okay, and we can see how the glow is changing over time. It's pulsing, anything. And I think it is a very nice effect. Let me just get out of this scene. Okay. I guess this could be sufficient as an example of creating a glow effect. I would leave the rest to the programmer's interpretation based on the type of game they are creating. Any suggestions for improvement are, of course, welcome in the comments. So have a wonderful day and see you in the next video.